Good morning, everyone. Good morning. How are you? How is everybody? Good? I have to say, I am more excited for this program than any of our programs this whole weekend because I love dinosaurs. So thank you for coming. I'm Andrew. I'm the director here, and welcome to our Sunday Family Day. We have programs all day today for all ages, not just kids. You can like dinosaurs and Native Americans and all the other programs at any age. So just to go over the schedule real quick so you know what's going on. This is our first program, Dinosaurs and Meteorites. And then at 11:30, we're going to have a program called Hands-on Native American Artifacts, where we're going to pass around arrowheads and spear points and all kinds of artifacts that you can touch. And then later at 12:30, we're going to show the film Adams County, USA. It's a 1-hour film about Adams County that was made by my good friend Jake Borrett. And then at 2 o'clock, we're going to do a program on Gettysburg in 1776 about the American Revolution. We have some other activities for kids with that one as well. And then another program at 3 called Children of the Battlefield about the kids who lived in the area during the Civil War. And then at 4 o'clock, we have a gardening activity with our friends from Hollabaugh who are bringing some activities for kids as well. So thank you for coming today. I'm really excited about the program. I'm going to introduce our speaker now. Really excited to have him here, Phil Eberspeaker. He is a retired aerospace engineer who served 36 years at NASA. So we're pretty excited to have him here today. Yeah, that's right. Phil oversaw the Sounding Rockets program and had traveled all around the world for NASA, working as a project manager. In his spare time, he founded and ran a hands-on science museum, and currently Phil teaches K-12 labs through the Advancing Sciences program at Gettysburg College. He has 2 grown children and a brand new grandchild. And his wife, Denise, is our Director of Operations here at the Adams County Historical Society. So thank you for being here, Phil. We'll welcome you up, and thank you all for being here today, too.
Okay, well, thanks for coming, everyone. I can talk loud enough, I think. So if not, just raise your hand. My wife tells me I'm always talking too loud, so.
If you don't mind using it, actually, we have it live streamed, so that way
okay.
people hear it.
Is there anything that, okay, is it on? Okay. All right, well, now I'll be a one-handed paleontologist wannabe. Okay, well, we're going to talk about a number of things. People come to Gettysburg and they're always thinking the Civil War, right? But there's all kinds of neat history here in Adams County that stretches all the way back to the dinosaurs and before. But how many of you here are from the Gettysburg area or Adams County? Raise your hand if you're from around. If you're from someplace else, raise your hand. Coming here just for a visit for the weekend. Okay, great. So I'm glad you were be able to come by this museum and get a little more history of the whole county from various different perspectives, not just the Civil War. And what I've been asked to come and talk about is dinosaurs and meteors, because we're sort of famous to a little bit extent that we've got a dinosaur footprints on display in the museum that came out of a quarry here in Adams County. So we're going to talk about dinosaurs and fossils and things a little bit. And then we actually found, we didn't find, but back in 1887, if I recall correctly, that a meteorite was found here, a pretty big one. And meteorites are those things, shooting stars you might see in the sky at night. So we'll talk about that a little bit and where they come from and all. And so we'll kind of learn that history, okay? So are you ready to do that? All right, okay. Well, so you can look at the screen a little bit, and I'll talk a little bit, and we got lots of things to touch and hands-on and check things out, so hopefully this will be a fun little experience. So we're going to talk about our dinosaurs and our meteorite a little bit. So let's start off with our dinosaurs. Okay, so there's one big question is, how long has there been life on Earth? Okay, actually the Earth has been around a pretty long time. The question is, how long? Would you have a guess?
20,000
and 4 hours, right? Yeah. What do you think?
like 65 million.
Okay, all right. Well, we all have hypotheses here. What do you think? 75 billion years. Okay, well, those are all good estimates, and that's what scientists do. You know, I'm sort of an engineer slash scientist, and you always try to figure things out, and you collect data over long amounts of time, and you kind of get better at your estimates every time you find something and discover something new. So again, that's what scientists try to do to kind of figure out, you know, what's happened way in the past and all that. And we'll talk about how old we think the Earth is and life is. And so, you know, how long has it been since dinosaurs walked the Earth? You know, it's always a big question. Oh, what do you think? You have an idea? 50? Oh, that's a pretty good number, I think, that you gave here. So we'll remember that, okay? That's good. That's actually pretty accurate. So, you know, how long ago did they die out? You know, because they've not been around for, we don't have, are dinosaurs running around outside now? No. But is there evidence that there were dinosaurs in the past?
Yes.
Okay, but they're gone now, right?
Yes.
So something happened to them. And you know what? It had to do with sort of a big, huge meteorite thing. One possibility, okay? Yes, real quick. Yes? Okay. Okay, all right, well, we'll see. We'll see if what your hypothesis is, okay? As you're a little scientist. Okay, so let's look at this, this little timeline here. I'm not going to go into too much detail, but way back here, 400 million years ago, they pretty much think that, and there's lots of evidence that kind of shows this, is that the Pennsylvania was pretty much under a shallow sea. All right, so right now we would be underwater. Okay, maybe 60 feet deep, 70 feet deep, not like the ocean that's, you know, 3 or 4 miles deep, but a shallow sea. And they have evidence of fossils and things that kind of demonstrate that that was a fact. Okay, and stuff in that sediment indicates that what was going on at that time. Back about 300 million years ago, kind of the water was changing, the land was uplifting, and there's evidence of ferns and things, and so it became kind of a swampy area, right? It's not very swampy out here right now, right? So it's a lot different than way back then. And then, this is the time of the dinosaurs. And you might be familiar with some of the words like Triassic, or how many have heard of Jurassic Park, the movie Jurassic Park about the dinosaurs? Well, that's kind of giving you the, this time frame here. About between 200 and 150 million years ago. And then there's this Cretaceous period, which is not quite as popular as far as movies say it, but that's where dinosaurs were. And here is where the evidence kind of indicates that the dinosaurs, or most of the big ones, kind of went away. There's no longer any evidence that, that there were dinosaurs. There were other things, plants, and there were fishes and turtles and alligators, but not the big dinosaurs. And look, this number here is about 50 million years ago. Didn't you say about 40 million years ago they went away? That's a pretty good number, right? So you have a good idea of roughly when we kind of stopped seeing evidence of the last dinosaurs. Okay, and the Earth was really quite different way back then. This is a long, long time ago, and I'm going to try to show you what that might mean here in a moment. But at this point, back in the Triassic, the Earth was kind of all one big blob of land. There's evidence here by looking at the rocks and the geology and things. So again, scientists look at all kinds of different things to try to piece together what things might have been like way back when. And then they start drifting apart. You can almost see it kind of looks like America here, but this is North America and South America. And that was back in the Jurassic time. And then the oceans kind of expand a little bit and land sunk down, so America looked a little bit different. And so some stuff was underwater, some stuff wasn't. Okay, so it was all changing. There's all kinds of weird things going on with the Earth's changes over many, 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 many years. Okay, so that's for the period to where we had our dinosaurs. Actually, the lands are changing. You know, one day is 24 hours. You get up in the morning and you go to sleep at night. But can you imagine how many of those days would be in all these years? A very long time. So let's try to get an idea of what that might mean. Here's my toilet paper timeline of Earth. Okay? Now let's see if this can sink in. It's kind of hard. You can see I can't conceive of what 400 million years looks like. But right here at the end of my toilet paper, I have a dot that says today. You probably can't even see my dot there that says today. And if I pulled out my hair, one hair, and I cut this hair into 100 slices, thin, you know, cut it in half, 100 half put it right here today, that thickness of that 1/100th of a hair is when the Civil War happened. Okay, so I can't even draw that on my toilet paper roll of time. Okay, and human beings kind of emerged around. And let's say that was about 1 million years ago. So right here, let's say, is about 2 to 3 million years ago. That little distance. Okay, that's many, 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 many generations of people. So now, let's see where our dinosaurs and things occurred. And unfortunately, the room's not big enough to put my entire 3.5 billion years since we think that there was life. So here we are today. And to give you a little idea, this is 65 million years ago, the end of the dinosaurs. Okay, then we come all the way here to where the beginning of the dinosaurs is. That's 240 million years ago. And we'll take a look at this little guy. This is a trilobite. We'll pass this around in a minute. This trilobite came from an area 450 million years ago, which is way back here, 450 million years. And like I said, unfortunately, the room's not big enough. Okay, that would go out and down the wall and out into the battlefield over there to kind of give you an idea of how long stuff has been around. Okay, and we're just right here, itty bitty, a little bit of time. And we've lasted about this long. Okay, since we kind of been around, but look how long the dinosaurs were around. They were around for like 150 million years. Huge time. I know you can't quite understand what that means because it's just so big. Sometimes in science, especially when you talk about space and stuff, numbers are so huge, you just can't figure out what they're saying. Too many zeros. Okay, but if we were here this long, you see how much longer the dinosaurs were around. Okay, so maybe that brings that home a little bit. The time is a long time. Okay, so let's take a look. And there's more and more dinosaurs. We were talking before the program. Back when I was a kid your age, there was a brontosaurus, a stegosaurus, a triceratops, and pretty much a brontosaurus. There wasn't that big, huge amount of dinosaurs that are known. Now, this is just a very small picture of a lot of dinosaurs that have existed over that long, long period of time. Okay, so here you can see the stegosaurus. I can pass around the stegosaurus. You're probably familiar with one of these guys, right? So take a look at it. You can pass it around. And there's an allosaurus. And let's say that this guy sort of is an allosaurus. And you kind of see how they are. But you notice how they kind of existed at roughly about the same time. This is the Jurassic period. And then in the Cretaceous period, you have your scary Tyrannosaurus rex, right? And your Triceratops that disappeared. Oh, Triceratops. Okay? So what's neat about that is there's so many of them. There are thousands of different kind of dinosaurs. And we just talked about there was one, a Tyrannosaurus rex-like dinosaur I just found. There's another huge Brontosaurus. Okay? But you know something that's a little sad for here in Pennsylvania is that we don't find many fossils of dinosaurs in Pennsylvania. That's a little sad. But we do find fossils of things before that. The mountains here are so old that they were actually formed before the dinosaurs existed. And so there's no way for them to kind of get trapped into the stone and become fossils over millions and millions of years. But let's look. Let me have the dinosaurs back. Yeah, you can set the mic there. Set them there. It's good. And let's look at some ancient fossils we can find in the Pennsylvania area and on the East Coast. Take a look at this. You can see it looks like a shell of some kind. Right? And this was trapped in this rock. And so you can kind of pass that around and take a look at it. That's probably 300 or 400 million years old, okay, trapped in the rock. Here is a little kind of like a bug thing that crawled on the bottom of the ocean. It's called a trilobite. And that was about 450 million years ago. Okay, so you can actually touch something that's really that old. And you can see, and I'll pass them on this other side. Oops. If you can look at this and start passing around, is if you look in here, you might be able to find in this rock, you might be able to find some shells and things that were compressed, or some imprints of shells. And can you see that here? You can go ahead and take it, and take a look at it, and see some shells and things. All right, so again, remember when I showed that picture that that Pennsylvania and North America were kind of underwater at one time? And that's where these shells come from. And here you can kind of see a little seashell that's imprinted into the rock. And I'm going to pass this one around. It's a little hard to see from here, but this is some ancient coral from when there was a sea and the coral grew way, way, way back. And actually, I'm from Michigan, and this would be known as a Petoskey stone, right? A fossilized coral. So you can pass that around. Look, you can look at this. Oops, that's some coral. Now, can anybody tell me what this is? What's this?
A dinosaur tooth.
Okay, it's a tooth from something way back, which is what?
Megalodon.
A megalodon. Okay,
Yes.
this is actually a small little megalodon tooth. And if you're looking around in the museum, when you go through the museum, if you are, you might want to look around and see if we have a bigger megalodon tooth in the museum. Right, so that's kind of neat to look for while you're in there. And these were really big, huge sharks. They could swallow me whole and not even know it. Okay, so take a look at that. And that's very, very old. And so you kind of see those neat old things. Some of these things you're touching are several hundred million years old. And it just so happened that over time, the Earth erodes away and kind of gets flat, and has now started to kind of show these things are found. And people say, "Oh, what's this?" And they study them and try to measure how old they are. And then we can start putting together this picture. Okay? And here's one other last thing. Anybody know what this is? What do you think this is? Not a T-Rex tooth. No. What do you think? A raptor claw.
Yes.
Boy, are you a paleontologist? You keep coming up with all you guys come with all these good answers. But it's a raptor claw, right? And we've got a little raptor right here, and I'm gonna pass this around with this claw. Now this is not real. This is actually a model made after a real claw. I couldn't afford a real raptor claw, okay? So I have to have a reproduction. And so he kind of comes from maybe a guy that looked like this, okay? So there's a sharp. But you wouldn't want to see one of those running around outside, would you? No, no, sir. Not me, anyway. So we have fossils from when there was an ocean here. Okay. Okay. And we have some fossils of mastodons and giant sloths and things after the dinosaurs. There are some evidence there. But we don't have a whole lot of evidence of dinosaurs in Pennsylvania, but we do have some evidence, and some of that is footprints. And we're going to talk about footprints in a moment, okay, that tells us, yes, indeed, there were dinosaurs here. All right, so let's hit that. Let's talk about some dinosaurs we think were in Pennsylvania at that time, even though we don't have fossils to show that, but we have other evidence that indicates they were probably around this area. And I don't know, our paleontologists, and we know there's somebody back here that knows things, can pronounce some of these dinosaur names. So can you read that name? What do you think? Ankylosaurus? Yeah, I can never be a paleontologist because I can't pronounce all their names. All right? And for some reason they come up with the strangest, it's like medicines. They come up with these strange names for medicines, and I don't know, can't even pronounce them. I'm on a whole bunch of them, and I can't pronounce any of them. Anyway, so there was this armored guy here, which is kind of neat. And you get an idea of how big it was relative to a person. Okay, they're not super huge, but they're pretty big. They're certainly bigger than your dog, isn't it? Okay, so I don't know if I'd want to have that running around my house and cleaning up after it. But and then there's these little guys. Can anybody pronounce this one? What's this pronounced? Plesiosaurus, okay, good. And running around on two legs. And then, a what? What do you think that's called? Okay, good, good. Now, do we really know what they look like? We know their shape. And every once in a while, we can find some skin that's been fossilized. And actually, there's a neat story that I just saw just the other day, actually, to where they found one of these in pretty good shape buried in the rocks. It was a fossil, and it was so well preserved it still had skin. The skin was actually stone. And they could actually see these plates and these spikes, and they actually had the head, and it was almost like 75% there. And that they hypothesized, because it was found out in the area where there was a lot of ocean. And in that shallow sea, and they figured that it died, and it was in the water, and of course when things die, they kind of bloat up because of gases that are produced in them, and it kind of floated out to sea, and then it burst because it got too much gases produced in it, and it sank down, landed on its back, sediment came in, buried it, and created this giant fossil of this guy. And so that's how they understand, well, this had skin, it had spikes, and that's how they understand sort of the shape of some of these dinosaurs. Now, do we know that they were furry in some cases? Maybe we find a little bit of evidence that indicates maybe they were. And sometimes there's enough evidence to maybe figure out from chemistry that they're the color of them a little bit. But a lot of this is artists trying to figure out what they think they might look like. And you can see this one is pretty big. I wouldn't want to go out and take out the trash at night and run on that guy at night. Would you? No, not me. And then there was this Hadrosaurus here that started walking on 4 legs. And you see how big it was. And then there's some littler guys. This one, I wouldn't be too afraid of this one. He's about the size of a cat. Right? Yes?
I think there's like some tiny bird, dinosaur. I forgot what the name was, and they're like as small as a can of soup.
Yep. There's some small things and all that. Yeah, they're all different sizes. And so anyways, there's a lot of variety of dinosaurs, and a lot of those they think were here in Pennsylvania. All right, but our evidence that we know and we can show, and we actually show in our museum here, is footprints. Okay, and these aren't huge footprints, they're relatively small. And we think, we don't know precisely since we don't have a fossilized dinosaur next to them, that it might have been a sauropomorpha type dinosaur that walked on 2 legs. And so some hypothesized that it was this guy. Again, relatively small. All right, so we're not talking about Tyrannosaurus rex. Or it might have been this guy. And again, maybe from some evidence they thought, well, maybe they were heavier or hairy a little bit. Maybe they had things like feathers, all right, because they saw some evidence in the fossils that said, well, maybe they weren't just like reptiles. Maybe they were a little different. And actually, a lot of birds today, you know what? They're dinosaurs. Birds actually kind of changed. They were kind of going at the same time of dinosaurs. Then the dinosaurs died out, but the bird-like dinosaurs survived. And then they kind of, over time, became the type of birds we see. So that's kind of weird, isn't it? How these animals have kind of changed over very long times of toilet paper, right, to get that distance. So maybe our dinosaur here was one of these guys. Okay, and where in the timeline do you think this guy falls? And it might be down here, sort of in the early Jurassic period, was when those kind of dinosaurs are running around. So that kind of gives you an idea of where we are. Certainly not a Brontosaurus or a Tyrannosaurus rex, but one of these little guys way back here early on, when dinosaurs were generally smaller than the big ones that we're familiar with in the movies and things, right? Okay? So let's look about the evidence that we have, since that's what we have in our museum. So what I want to do is, if there were millions and millions of dinosaurs running around over millions and millions of years, wouldn't you think there'd be a lot of footprints in the ground? Why don't you think there would be a lot?
Because the rain would wash it away, and then also other dinosaurs would go over their footprints.
Okay, there's erosion and rain and things like that, and the soil had to be just right. So I need a volunteer. Let's start off with you. Okay, now I have my footprint, and this is a footprint of the dinosaur that you'll find in the museum, or a close model of it. And I have 3 soils. I have this kind of dry dirt, I've got sand, and I've got a muddy spot. All right, what I want you to do is I want you to be a dinosaur and you step into the sand. Go ahead and push it down in the sand as hard as you can. Oh, you're a heavy dinosaur. All right, good. Okay, thank you. Now, let's pull that apart, and I'll show us around a little bit. You can kind of see a footprint in there, right? Yeah. So there's evidence that the dinosaur was there, but what if the wind blows and it rains? Did the footprint go away? Can you see the footprint much? Right? Or the wind blows and it kind of goes away, doesn't it? So this dinosaur, your dinosaur, didn't step in the right spot, did it? No. Okay, nope. So that footprint doesn't get preserved. Now we have dry soil. So why don't you, oh yeah, you had your hand up. You be our dinosaur stepping in this dry dirt. Okay, stepping down real hard, it's a heavy dinosaur. Okay, that's good. Pull apart. Now take a look. Can you see much of a footprint?
No.
Not really, right? You think that would survive and become a fossilized dinosaur footprint? No. And of course, if it eroded and rained and all that, it would kind of go away, and I wouldn't get a footprint in either of those soils. But now, what do you think if you stepped in the mud? What if you stepped in, oh, she really wants to step in the mud. Step in that mud good. Okay, walk around, stepped out, okay, go ahead and pull it off. Okay, now, look at that footprint. Is that a pretty, can you tell that's a footprint?
Yes.
Yes. And then let's say it started to dry out. You think that's going to become kind of hard and kind of stay there for a while? And maybe the wind wouldn't blow it away, or if it rained a little bit, it might stay there. And then maybe some sand kind of gets washed over it after it's dry, and it fills up, and then dirt kind of gets piled on top of it, and that happens for millions of years, and all of a sudden all this weight squishes down and can preserve that footprint. And then it becomes stone. And if you go into the museum, right at the entrance there where we start off with prehistoric times, you'll see the actual stone rock that the footprints are captured in. And you'll notice it'll look a little bit like this. Okay? So it takes a lot of luck to step in the right stuff at the right time, and then the right stuff happens after that to be able to capture that and preserve it for us to study many, 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 many years later. All right, and it doesn't happen very often. Now, especially here in Pennsylvania and on the East Coast. Now, my brother, he lived in Texas, and there's all kinds of places where there's footprints out in Texas because the conditions, the soil and the weather and all that were right, so they capture a lot more footprints. But it's a little hard here on the East Coast. All right, so when you go in the museum, I want you to look for that footprint, and now you'll know how it was produced, okay? All right, now, let's move on to the next thing, because I'm probably sure I'm running long here. But let me move this out of the way. And maybe afterwards, there's some time you can come and play around with some footprints. Okay, thank you. All right, and here's our timeline. I can always make another one, right? So let's, there's plenty of toilet paper. Well, you remember the pandemic and it was hard to get toilet paper? So, whoops. So maybe I want to save that for just in case. So let's, so here we are in the quarry that the footprints were found. And then somebody just kind of, they were digging out and they found the footprints, and then they said, we better preserve those because there's some historical significance there. So they cut them out of the stone, and we've actually got a sample of those footprints. Okay? Any questions about that? Was dinosaurs around a long, long, long time ago?
Yeah.
Yeah. Did they live a long, 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 long time?
Yeah.
Yeah. Compared to them, have we lived a long, 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 long time?
No, we've only lived like 10,000.
We've lived a dot, right?
Yeah, like 10,000-ish years.
Right. So they've been around for a very. So everybody said in the old times when we were kids, oh, dinosaurs were unsuccessful. They died out. Well, they lived for 150 million years.
Yeah.
So that's pretty successful, if you ask me. Right.
The size of Mars.
And that is a good lead-in to our next topic, meteors. Okay? So let's talk about those, because we have one or bits of one in our museum that I want you to look at. So let's look at some famous meteors. And since we've talked about the dinosaurs, okay, let's look up here. Let's look up here. And go, oh, uh-oh, our timeline's moving away. Time is moving backwards. We're moving back in time. Okay, all right. So we talked about the dinosaurs ending, and our paleontologist over here said about 40, 50, 60 million years ago, the dinosaurs died out. And there were lots of theories. Scientists thought lots of different ways the dinosaurs might have died out. But actually, most bestest evidence is that there was a meteor that hit the Earth. And this particular one hit down here in Mexico on the Yucatan Peninsula. Well, you're going to learn about that in geography class in school someday. All right? But that was a huge, huge rock. It hit about 65 million years ago, so it kind of coincided. It was at the same time that the dinosaurs kind of went away. It was probably about 6 or 7 miles in diameter. Now, if you go to the battlefields while you're here, and you go to Seminary Ridge, you know, where the battles kind of started and things, and you look out towards the mountains to the west, all right, you'll see a range of mountains. Those are about 6 or 7 miles away. So from that Seminary Ridge, looking out, way out to those mountains, and if you're familiar with this area, Ski Liberty area, and it's actually easy to see in the wintertime because you can see the ski slopes. But anyway, that gives you an idea of how big the rock was that hit the Earth way back then and caused this big, huge splash and threw all kinds of stuff in the air, started fires, and there was the beginning of the end of the dinosaurs. Okay? So that's a big, huge one. But we don't have a big, huge meteor like that here in our museum, unfortunately. But that's a big, huge, famous one. Okay, so now let's look at, oh, and by the way, that crater is 110 miles wide, and the hole in the ground it made was 12 miles deep. Okay, so that was a big crunch. Now, here's another famous crater. Maybe you Meteor strike. This is out in Arizona, and it made a big hole in the ground. But this one was about 150 feet wide. Okay, so here's my model of that meteor. I had no idea what it looked like, okay, but I'm just kind of guessing here. It's not really a piece of rock, it's just a model. How big do you think a person would be relative to this meteor? How big do you think? This tall? This tall?
Like a grain of dust.
Grain of dust? Okay, well this is 150 feet long, and here is my 6-foot-tall astronaut. And so that is roughly how big that meteor was that hit the ground out there in the desert. Okay? Boy, don't meteorites feel funny? Or styrofoam, it depends on what you think it is, okay? All right, so here we have the, uh-oh, now you're going to be all messy and have brown stuff all over you. But, get approved. All right, so our 150-foot diameter meteorite and our 6-foot person kind of gives you an idea how big a chunk of rock that was. But we don't have that big meteor here in our museum, unfortunately. And actually, it kind of disintegrated when it hit the ground. And you want to know something that's funny? A lot of these meteors are made out of iron, and we're going to learn about why they are. But somebody thought that there'd be lots of iron. They found iron there, and they were going to try to prospect there and find an iron mine and mine iron and become rich, because they're going to recover all that iron from that meteorite. They never did find it because it was spread all over the place. Because it made a big bang and crunch when it hit the ground too. Can you imagine a thing that's a football field across hitting the ground? So being that big compared to that guy. Okay, so but let's talk. If I can find my controls and things about other meteors that we're more familiar with. How many have seen a shooting star in the sky? A little streak of light in the sky, raise your hand. Okay, how big do you think those are? Are they big, like 150 foot big? Are they 6 miles big, or are they smaller, or what? A little shooting star, what do you think? Don't tell me you're an astrophysicist too.
They can be big or small.
Okay, they can be big or small, right? It depends on how long they last. Now, most of the shooting stars you see are probably no bigger than this. Put your hand out. Okay, put your hand out. A speck of sand, right? And they are flying so fast that they burn up here. I'll pass out a couple more. Here's a couple more little meteorites, meteors, itty bitty, really small, right? You can pass them around if you don't drop them, okay? But they're very small. Right from here, I'll pass the whole bag around. You can take your souvenir meteorite with you. Okay?
Yay, thanks.
Only $7.95 each. Okay?
I mean, at least.
Now, gotta make a buck somehow. All right, now, sometimes you might see a shooting star that breaks apart. Has anybody seen a shooting star and all of a sudden it kind of breaks apart and you see a whole bunch of little pieces of light in the sky? Have you seen something like that? If you're very lucky, sometimes you do. They might be, uh-oh, we have meteorites all over the floor. That's okay. But,
Yay.
boy, let's see, 1, 2, 3, 4, 10, 20. Oh, that's a lot of money. That's okay, don't worry about it. Now, this is maybe about how big one of those might be, that you might see. It might last for a couple seconds across the sky. And then it might break apart because it gets hot and explodes, and they might be this big. So like you said, they could be different sizes. Small as a grain of sand, that's the typical stuff we see. If you're lucky, maybe a few times in your life, you'll see something this big come in. All right, but way back in the 1800s, someone was on their farm here in the Adams County area and found this big chunk of thing on their farm field. And that big chunk of thing was this. Ooh. Okay, this is a model of the Mount Joy meteorite that was found here in Adams County. Now this is close to being full scale. That means it's as big as it actually was when it got here. And let me see how late I am. Okay, not too bad. All right, and you know how much this thing weighed? How much do you think this thing weighed when they found it? What do you think? 10 tons? No, not quite 10 tons.
1,000,000 tons.
1,000,000 tons. That's a lot. That's a lot of tonnage.
That's like.
But this guy, I don't remember. I can put my slide back up. This guy was like 300 million tons. It was big and heavy. Okay? So this thing was what? One last guess.
30, 40 pounds.
30, 40 pounds. That's a closer guess, right? But it was about 847 pounds. All right, that's a lot of stuff crammed into this rock. Here, you can hold on to that meteorite. Ugh. Okay? It doesn't weigh 800 pounds. It's made out of styrofoam. All right? But it kind of shows you how big it is. But you notice how weird the shape is? It's not like a round stone. And so that's kind of weird. Yeah, go ahead. Pass it around. Go ahead and pass it around. This meteorite one costs $720 if you want one. Okay, not really. They're not for sale. Not like, come on, pass that back there and let them check it out. Now, take a look at the shape. And when you go into the museum, you might see a picture of the meteor. Okay? All right? Okay, quick, pass it back there so we can do a quick touch. Okay? So, anybody know where meteorites come from? Well, first of all, in space, they're meteoroids. Okay? And then when they get in the atmosphere and you see them like a shooting star, they're meteors. But then when they hit the ground, they're called what? Meteorites. Right? Okay, so they kind of those three phases there. So this they found on the ground, so that is a meteorite. A shooting star is just a meteor. Okay? And this chunk of space stuff floating around in space is a meteoroid. So, so anybody know where they come from? Where do they come from?
They break off of planets.
They sometimes can break off from planets. They found evidence of meteorites that were from the moon. So when an asteroid, another big chunk hits the moon, it throws stuff out, and some of that time might make it to the Earth. What do you think? Okay, not a black hole. Nothing can get out of a black hole. Not even light.
Not even light.
But that's another lecture.
Like,
Right? Okay. Well, that'll be our astrophysicist over here. We'll teach you just that later on. Okay, but they come from Mars. There's some evidence to possibly Mars, and hopefully when we get back some samples from Mars, they're actually collecting samples now with a robot and leaving them there, so we'll pick them up later with another robot, and we'll be able to compare some of those samples to maybe what we have some samples here. Okay, guys. All right, I'm gonna take my big meteor back. Okay. Now, and they come from this place called the asteroid belt. And that's actually between Mars and Jupiter. There's a crunched up planet that never quite formed, and it's a ring of big chunks of rock and ice and stuff. There's also comets, which are made out of ice, and they come from a place called the Oort cloud. And the Oort cloud's out beyond Pluto. And they think it could stretch anywhere from Pluto out to 2 light years away. Really, again, here we are, space, and all these big, huge numbers. And it's a big cloud all over everywhere that some of these comets come from. Okay? So that's where some of these meteorites might come from. So what I think, this is my theory of the birth of the Mount Joy meteorite. Okay? Now, I had a meteorite that's been floating around out there for billions and billions of years, and stuff's kind of collided over time and got bigger and bigger. And inside the middle of my thing floating out there in the asteroid belt is an iron core. And around that iron core is rock. And we know that because when these things were formed, they became hot. And iron melted. And believe it or not, melted iron will sink through the other rock and want to go towards the center of things. That's why the Earth has an iron core, because it's so hot inside, it's melting in magma, and it's melting in, and all the iron is sunk down to the inside of the Earth. The same sort of thing happened with things out in the asteroid belt. But then, so you got rocks of different types, and then here's our green striped iron core. But then, all of a sudden, another asteroid or rocky thing started floating by, and they crashed into each other. Bang, crunch, pop. And lo and behold, our Mount Joy meteorite was born. So this iron chunk broke free, and somehow, just by chance, happened to float by Earth, and it was thrown in Earth's direction, and so it came cruising in and crash landed in Adams County. And I don't know if that was thousands of years ago, if that was hundreds of thousands of years ago, or millions of years ago. It's hard to tell. We know how old this thing is, but we don't know when it hit. Okay? We just don't have evidence that tells us when it hit. All we know is back in the 1880s, a farmer stumbled across it on his farm field and said, I don't know what that is. You know what? He set it aside. Well, that's interesting. He kind of set it aside and didn't think much of it, but then he kind of thought, well, that's a big chunk of iron. Maybe there's a bunch of iron around here somewhere, so let's start looking for it, and we'll have a mine, and we'll make money by selling iron. But they never found anything. And then many, many years later, they realized, you know what that is? That is a meteorite. That came from space. And it was that iron chunk that happened from that collision. Okay? And let's go back in time. So here's, you're going to see a picture in the museum. And again, I think it was found in 1887, if I have my date right. It weighed 474 pounds, made out of mostly iron. And like I say, they didn't quite know what it was initially. So that looks pretty similar, right? It's not perfect, but my full-scale meteorite kind of matches that thing, right? Okay, we've got to wrap things up here shortly. But and there's lots of evidence, and again, we're a historical society here, so we try to keep all these records that tell us what's going on. So here's evidence that was recorded and put in the newspapers for the meteorite, and here are our dinosaurs and our tracks. So actually, if you want to go into our research area, you can research all sorts of things about Adams County here in this museum. So it's neat that we have this place to come and find these sorts of things. Now, there's one thing I kind of forgot to show you. Everybody move back just a little bit. I was so excited about everything else I was talking about, I forgot that here is about the size of our little footprint that you're going to see in the museum, if you can find it when you go inside the museum. All right? And we think that that dinosaur was about, why don't you stand up? Stand up. Stand up and stand like this. And face everybody else. This is probably about the size of the little dinosaur that made this footprint. And this is his little buddy next to him. And they were hunting little worms and things. You guys like eating worms and stuff like that? But that's about how big you were. Now, let's look at this. Oh, my goodness, hit me in the head. You got hit in the head by a what? Massive. Okay, what do you think that is a footprint of? Is that me? No? What do you think that is a footprint of? I think you're pretty close on what that might be. Can you get that green guy over there? The green dinosaur. There you go, that guy. Now this is the old classic Brontosaurus. All right, now there's actually lots of dinosaurs that are a lot bigger than this, but this is a little paper model of the biggest dinosaur footprint they found so far. Right? So I want you all to try to sit in that footprint. Quick, get in there and sit in that footprint. How many kids can fit into a giant Brachiosaurus footprint? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that's good. All right, thanks. So 10 little kids can fit inside one Brachiosaurus footprint. Oh, and one teddy bear. Forgot about the teddy bear. Now imagine this. Look out the window out back. And you have this giant thing walking by, and his shoulder is at this window. Can you imagine something like that walking around and leaving footprints like this? And how many have to go out in the yard and pick up after your dog? Would you want to go out in your yard and pick up after this guy? I would need at least a shovel, if not a front end loader, right, to pick up after that. So I don't think I'd want one of these guys as a pet. Would you?
Yes.
Yes? You think so? Okay. One last thing. We've got a couple more minutes here. Let's go back to our asteroids.
Yes.
Now. Oh, wait. Let me add these. Let's okay, back up a little bit. Now remember I talked about the asteroids or the meteors when they hit the ground, and we made that big, huge, 12-mile deep. What's this stuff? What do you think this stuff is? It's kitty litter. Kitty litter. And oh, by the way, it's used kitty litter. So you all have your hands in it. Okay? No, it's not used kitty litter. Okay, let's get our hands out of there for a minute. Everybody stand back. You think a footprint would go in there good? I don't think so. I don't know where my hat and a footprint. Might make one, but it wouldn't last very long, would it? Okay, but we're not talking about that. Let's talk about a meteor coming in. If this meteor hits the ground, what do you think it's going to do?
It made a hole.
Is it going to make a hole? And did anybody know what we call those holes? What do you think? Craters. Okay. And as you look at the moon at night, you'll see lots of craters on the moon. And if you look in this kitty litter, you see a lot of handprints. Right? Okay, so everybody move back a little bit, and let's see if we can make a little crater. So let's make a bigger thing comes in, and hopefully it won't splash on you, but let's make a crater. Okay, so here's our, okay, let's look at our crater that's made. You see how it kind of blew some stuff out, kitty litter out, when you hit the ground? Now if I have this really small, which one of these is heavier? Which one of these is heavier? This one, this big one is heavier, and this is just a little light ping pong ball. Which one of these meteors do you think would make a bigger hole in the ground?
That one.
That one, you think so?
That one.
Okay, so let's do an experiment. I want you to stand up. All right, hands out of the kitty litter. An experiment here. And I just want you to hold these both up at the same height. And I want you to drop them both in the kitty litter, and let's see what happens. Okay, go ahead, drop. Okay, small. Okay, so here we have a small meteorite. Did it make much of a hole?
No.
No. So now we have a big meteorite. Did it make a bigger hole?
Yes.
Yes, it made a bigger crater. So you know, as the bigger and bigger the asteroids or crater or meteors are, make bigger and bigger holes in the ground. And they're actually finding lots of craters in the ground now. We can look into we use radar and sonar type things to look through the ground, and we can see how big they are. One last thing, everybody stand back. Okay? So we had paleontologists, we had astrophysicists, now we're going to be physicists. And I'm going to ask you a question. To wrap things up here, I'm going to ask you one question. You said that this was heavier, right, than this little guy. If I drop these two at the same time, which one's going to hit the ground first? The heavy one or the light one? The heavy one? Light one? The light one's going to hit the ground first? Want to do an experiment and see?
Yeah.
Okay. All right. I'm going to want you to count down. 3, 2, 1, drop. And we're going to see which one of these hits the ground first. Heavy one or small one? What? 3, 2, 1, drop. Same time. That's kind of neat, though. Why isn't the heavier one hit? Isn't it heavier? 3, watch your fingers. Watch your fingers. Watch your heads, too. Boom. So 3, 2, 1, drop. Okay? All right. Any last questions? We've got to wrap up. And if you want, we can stay around if we have some time and play around a little bit more. But question? Oh, what question did I ask?
You said, why does the...
Okay. Why? Do you know why they hit at the same time? Why?
Because of their shape.
The shape? Well, that's one thing. Yep. That's why I use the same shape, so the drag, the air doesn't mess up my experiment. But stone. Oh, everybody, out of the kitty litter. Go, cats. Let's look at shape. Let's do an experiment. I just love you start getting me to do experiments. I just can't stop. Okay. All right. So let's drop a plastic brontosaurus, and a wooden ball. Which one's going to hit the ground first? Dinosaur? Let's see what happens. 3, 2, 1, drop. They hit the ground at the same time. So it doesn't necessarily mean shape. It's just that gravity affects them all the same way.
Gravity
Okay?
and somewhat aerodynamics.
Right, and aerodynamics comes into play. That's why I try to use the same size. Geography. Well, you're sort of right. You know what? Gravity's a little bit different where there's big mountains than it is where there aren't. But we're not going to get into that either. So, okay, anything that's it. Thank you very much. And enjoy the rest of the day. Go in the museum and have a good time. You want to make some craters, Yeah, keep your hands out so you don't get hit by falling meteorites. Keep your hands out. Whoa, 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 whoa.